I want to look at a sample calculation using the Nernst equation. So we can calculate E cell for a voltaic cell made of zinc, and zinc's ion, and hydrogen ion, half cells. With the following conditions. At 25 degrees Celsius. So the concentration of zinc ion is equal to 0.010 molar. The concentration of hydrogen ion is equal to 2.5 molar. And the pressure of H2 is equal to 0.30 atmospheres. So in order to do this equation, I need to look up the cell potentials of zinc and hydrogen. So when I do that, I see hydrogen plus 2 electrons yields H2. And that means I'm going to need a 2 out in front here. And my E cell is 0.00. And zinc plus 2 electrons is equal to negative 0.76. So the first thing I need to do is calculate my E cell to see what is being oxidized and what is being reduced. So when I do that, I can try putting my zinc first, which would give me a negative cell potential. So I know that's not going to be the case because I need it to be spontaneous. So if I flip them, that gives me a positive cell potential. So what that means is my hydrogen is at the cathode. That means it's being reduced. And my zinc is at the anode, and that means it is being oxidized. So I can come up with my overall chemical equation. So I know that zinc is being oxidized, so I need to flip my equation. I'm going to start off with solid zinc. Hydrogen is being reduced, so I can keep the equation, the reaction, as it is. And notice the electrons are already equal, so I don't need to multiply the reactions by anything. We'll have 2 electrons being transferred. So I also know that this is not standard, so I'm going to have to calculate Q. But I notice that I'm given a pressure for hydrogen, so I need to calculate the concentration of hydrogen. So remember, the concentration of hydrogen is going to be equal to moles per 1 liter, and I can use the ideal gas law to do that. So it's just going to be P over RT. And my pressure is 0.30 atmospheres. R is the gas constant that deals with the unit pressure, so it's 0.08206 liters times atmospheres over moles times Kelvin. And then we can multiply that by the temperature, which is 25 degrees Celsius, or 298.15 Kelvin. And when we do this, we get 1.2 times 10 to the negative 2 molar for the concentration of our hydrogen. So now I can calculate Q. My expression for Q is going to be the concentration of H2 times the concentration of zinc ion divided by the concentration of hydrogen ion squared. And I can just plug the values that I got from up here and what I just calculated for hydrogen in to get my Q. So I will have 0.012 times 0.010 divided by 2.5 squared. And when we do that calculation, I get 1.9 times 10 to the negative 5. Now that I have that, and I have my standard E cell, I can plug that into the Nernst equation. So I have E cell is equal to standard E cell minus 0.0592 volts over N times the log of Q. Now keep in mind, I'm using this right here because I'm limited to 2 sig figs already based from my concentration and pressures, and I'm at 25 degrees Celsius. If I had more sig figs and I was at a different temperature, I would have to use the other equation. So my E cell I calculated to be 0.76 minus 0.0592 volts over 2 moles of electrons. That we get from our equation up here times the log of Q, which is 1.9 times 10 to the negative 5. And when I do this, I get 0.90 volts. And this is a spontaneous process, which is good because we're calculating E cell for the voltaic cell. Now we can take this one step further and calculate delta G. And in this case, we would have to do delta G with standard G and then plug it into the other equation for delta G